Assalamu alaikum student, welcome you once again, and we are again back with class 9th mathematics. The book is same, that is class 9th mathematics under Khyber Pakhtunkhwa board Peshawar. Now student, today we are going to start with exercise 1.3, but before going to start 1.3 we have to discuss what are the rules to add or subtract two matrices. Students, same as equality of two matrices, the rule are mostly same as for addition of two matrices. If the order of two matrices are same, this was a condition which we had used in equality of two matrices. If the order of the two matrices are same, then you can say that these matrices are conformable for addition and subtraction. Look here. Here it is a matrix A and this is matrix B. Now, the order of matrix A is 2 by 2, while order of matrix B is 2 by 2. So you can say that both A plus B is defined, or A plus B is conformable for multiplication and subtraction. Now, they are conformable for addition and subtraction, but how to add these two matrices? Look here, student. You have to add the corresponding entries. After finding out is that the order of both matrices are same, you have to add the corresponding entries, like 2 and its corresponding entry is 5 in the second matrix. So 2 plus 5, then 3 plus 6, then 1 plus 7, then 4 plus 8. And by adding them, 2 plus 5, 3 plus 6, 1 plus 7, 4 plus 8, you will get your resultant matrix. Keep one thing in your mind, student. The order of the resultant matrix will be same as the order of two matrices. Look here. The order of matrix A was 2 by 2. The order of matrix B was 2 by 2. The order of A plus B is also 2 by 2. So by adding two matrices, there is no change in the order of the resultant matrix. Now over to another example. Now look here, student. Again we have the same matrices with the same order 2 by 2. Now how to subtract them? Again, 2 and its corresponding entry is 5. 3 and its corresponding entry is 6. 1 and its corresponding entry is 7. Similarly, 4 and its corresponding entry is 8. You have to subtract 5 from 2, 6 from 3, 7 from 1 and 8 from 4. Look here, student. 2 minus 5, 3 minus 6, 1 minus 7, 4 minus 8, and this is your resultant matrix. And once again, the order of the resultant matrix is same as the order of the two given matrices. Okay, student. So again, I am repeating this thing, that student, there will be no change in the order of the resultant matrix. Now student, we will start from exercise, but keep one thing in your mind, that I am starting my exercise from question number 2 to get more and more knowledge about addition of matrices. Student, question number 2, page 19, exercise 1.3, and what he's asking us from us. He's asking from us, multiply the following matrices by the real number as indicated. This is a number, a single number, not a matrix. He wants us to multiply this number by this matrix. So how to start after solution, which is a very important phase in our question. Multiply, okay, multiply A. Multiply A. A is what? Our matrix with 2. Now look here. This is our matrix A. Multiply both sides by 2. That's why I'm using implies that sign. So look here. It will become 2A. So this is 2 and this is our matrix A. So look here, student. 2 ones are 2, 2 twos are 4, 2 threes are 6. And this is our resultant matrix. Now student, look here. What was the order of my matrix? It was 3, by 1, like 1, 2, 3. Three rows and 1 column. Now look here, student. After multiplying a single real number, there is still no change in the order of my resultant matrix. So student, what I want to tell you that by multiplying a single real number with your matrix, it will not change its order, okay? The order of the matrix was 3 by 1. Similarly, after multiplying this single real number, not matrix, single real number, the order of the resultant matrix is also 3 by 1, okay? Student, over to question number 2, part 2, page 19. Again, this time we have a real number, but it is P. P is also a real number, just like 1, 2, 3, 4, 5, okay? So look, again, multiplying both sides of this matrix by P. So it will become PB, and multiply P with A, PA, PB, PC, PD, PE, PF, and this is your resultant matrix. Once again, student, there is no change in the order of this matrix. Look here, what was the order of this matrix? It was 2 by 3, 2 by 3, okay? And what is the order of the resultant matrix? It is also 2 by 3. Look here, 2 by 3, 2 rows, 2 column. So again, I'm repeating myself once again that multiplying a single real number with a matrix cannot change its order. Its order will remain same. Okay, student? Now, student, over to the very first question of exercise 1.3. The page is same, that is 19. Student, why I have started with question number 2? Because few concepts relating to question number 1 were hidden in question number 2. So now I am starting with question number 1. What he is asking from us? He is telling us that let A and B are 2 by 3 and let C and D are 2 by 2 matrices. Student, kindly make some possible changes in your this question. Over to book page 19, exercise 1.3, and kindly note down this change. Look here, student. Over to your book. Look here, student. 2 square matrix. Kindly change it with 2 by 2 matrices, not 2 square matrix. Change it by this by 2 by 2 square matrices. Okay. Now look here, student. He has given us 4 matrices, A and B, C and D. The order of A and B is 2 by 3, while the order of C and D is 2 by 2. What he is asking us? That keeping the order of the matrices, find either few parts of question number 1 are defined or not. In simple word, their addition is possible or not. And if their addition is possible, what will be the order? Okay, he is using the word define. Define means that is it confirmable for addition or not? So look here, student. The first part is A plus B. The order of A is 2 by 3, while the order of B is 2 by 3. Order is same? Yes, we can add A plus B. In other words, you can say that A and B is defined because they are confirmable for addition. So, what will be the dimension, their order? Dimension means order of the resulting matrix. So, if you will add A plus B, the order will be 2 by 3, same as the order of A and B. As I told you, by adding 2 matrices, there will be no change in the order of the resultant matrix. Okay, student? Over to question 1, part 2, same page 19. B plus D. Student, what is the order of B? 2 by 3. What is the order of D? 2 by 2. Now look here. The order of B and D are not same. So they are not defined, my students. So you can say that they are not defined, or simply they are not confirmable for addition. Why? Because the order of B is not same as order of D. Okay. Over to part 3, student. 3A minus 2C. Now look here, student. The order of matrix A is 2 by 3. But here we had 3A. We have 3A. So multiplying this single number with A will not change the order of A. As I told you in question number 2, that by multiplying any number with the matrix, it will not change its order. So look here, student, by multiplying 3 with matrix A, whatever the order of A is, there will be no change in its order. Similarly, now what is C? The order of C was 2 by 2. Then what is the order of 2C? It will again 2 by 2. But look here, student, order of 3A and 2C are not same because 2 by 3, 2 by 2. So again, 3A minus 2C cannot be defined. They cannot be added. They cannot be conformable for addition because the order of 3A and 2C are not same. Okay, so they are not conformable for addition and subtraction. Over to the fourth part. 7C plus 2D. Now what is the order of C? 2 by 2. What is the order of 7C by multiplying 7 with our matrix C? It is 2 by 2. Once again, there is no change in multiplying a single real number. Over to D. 2 by 2. Multiply 2 with D, you will get 2 by 2. Now look here, student. The order of 7C, 2 by 2. The order of 2D, 2 by 2. Now you can add 7C and 2D because both have same order. So you can say that 7C plus 2D is defined. Okay, student. Student, over to question number 3. Now this is slightly changed question. He's asking us in question number 3, pages 19, exercise is same, that is 1.3. Find matrix X. Find a matrix X such that 4X is given to you. Like he wants us to find this X. Okay. But with the X we have a 4 which is multiplying here. Okay. Now look here how to start after solution. We have to find X. X is matrix when 4X is equal to this. Now student, we have to get rid of this 4. 4 is multiplying with this X. So what I am doing, I am multiplying 1 over 4. What does this 1 over 4 mean? Okay, student, this 1 over 4 means that 4 ones are 4 divided by 4, like 4 divided by 4. This is same as 4 divided by 4. Okay, 4 ones are 4 divided by 4. So by this mean we can cancel 4. So you can also use the step that multiplying both side by, dividing both side by 4 or multiplying both side by 1 over 4. Okay, both are same. Once again, dividing both side by 4 or multiplying both side by 1 over 4. Both will give you the same result. So by this, 4 will be cancelled from left hand side and 1 over 4 will be here. Now step 2. It means that multiply this 1 over 4 with 1, with 2, with 1, with 4, with 2, with 3, with minus 1, with 9, with 7. Same as it is. Okay. Now look, 1 ones are 1 divided by 4. 2 ones are 2 divided by 4. 1 ones are 1 divided by 4. 4 ones are 4 divided by 4. 2 ones are 2 divided by 4. 3 ones are 3 divided by 4. Minus 1 ones are minus 1 divided by 4. 9 ones are 9 divided by 4. 7 ones are 7 divided by 4. Now student, look here. Simplification of 2 over 4 is possible because 2 ones are 2, 2 twos are 4. So answer is 1 over 2. 1 over 4 cannot be further simplified. 4 over 4, 4 ones are 4. Answer will be 1. 2 ones are 2, 2 twos are 4. Simplification is possible, 1 over 2. Simplification is not possible. Simplification is not possible. Simplification is not possible. Simplification is not possible. So this is your final answer. So we are done with our remaining resultant matrix, that is X. And this is our complete question number 4 of exercise 1.3. Thank you very much, students.